Methane pollution is a result of dairy farming. Project by Kirsten, Jordan, Devon, and Hannah.
Mass transfer is the net movement of a solid or fluid from one location to another. The most abundant and reactive pollutant released into the stratosphere is methane. As methane diffuses towards the stratosphere, it is replaced with air. When the molar fluxes of two separate species are equal but moving in opposite directions towards each other, it is considered equimolar counter-diffusion. This mathematically derived experiment uses a basic diffusivity model to calculate the amount of dairy cow-related methane that currently resides in the stratosphere. The data implemented in the calculations is based on straw-fed North American dairy cows.
Dairy farming is a leading contributor to the release of methane into the stratosphere. Methane has a lifespan of 12 years and is considered a greenhouse gas that traps heat, resulting in global warming. This leads to further melting of the Arctic's permafrost, extreme weather, and production of greenhouse gases such as carbon dioxide and water. Dairy cows have a huge intake, which increases fermentation and the production of methane. This creates a direct relationship between methane emission and the size, growth rate, and production. Dairy cows are considered the biggest contributors out of all livestock because of the straw-fed and high-protein diets provided by confined dairy operations.
Calculations begin with Fick's first law for diffusion of methane. By using an equimolar diffusion model, the shown equation was derived to solve for the concentration of methane in the stratosphere. The concentration in the stratosphere depends on the molar flux of methane produced, diffusion coefficient of methane into air, height, and ground level concentration of methane.
In this scenario, the transfer of methane into the air is assumed to be modeled by steady-state diffusion, which does not account for wind. A perfect equimolar counter-diffusion implies various assumptions. One being that as methane diffuses, it is replaced by air in a straight path. Other assumptions consider the system closed, with no methane reactions and the temperature and pressure conditions throughout the stratosphere remaining constant.
One approach to measuring the surface-level methane concentration was accomplished using a gaseous plume from solid waste storage. In range, concentrations were measured downwind of the plume. Likewise, the concentration of methane was measured directly above the waste in an enclosure. Concentrations were determined alternatively through a fast box method. In this procedure, a box is placed over an emitting surface where the airflow was allowed through a pipe directly connected to the spectrometer.
Preventative measures can be taken to lower emissions and prevent future destruction of the earth. Since dairy cows are a leading cause for these emissions, they will be the focus of future contributions to decreasing methane output. Lowering or removing dairy products from human diets is a very simple solution because of alternatives such as nut and plant milks. Owners of dairy operations could also be regulated to enforce well-balanced nutrition for their livestock. These contributions could be further expanded to other livestock as well to reduce methane emissions further. Thank you and rock chalk!